call module is divided in 3A and 3B. 3A is related to low TRI technologies, and call module 3B is related to high TRI TRL technologies. So the 3A is research-oriented initiatives and actions, while 3B is innovation-oriented initiative and actions. The call module touch and go deep in the technology for power production. And so the idea is to fund projects focusing on advancing renewable energy technology for power production plant. Targeting technologies include bioenergy, concentrated solar power, photovoltaics, wind, ocean energy, as well as hybridization and integration of those technologies by themselves and in also with storage solution. Project aim to meet specific set plan implementation target for cost efficiency, circularity, and sustainability, and of course are in line with the goals of the EU energy strategies and renewable-based power system goals. Next slide. If we go more on the tail of the different technologies, we can see that bioenergy mainly take into consideration BECCS for power generation, so high efficiency biomass co-generated of power with improved performance and higher share of power production. So we can also take into consideration power project with having power production together with the production or other energy vectors. The important point is that the power production is a significant amount of the energy produced, and of course the possibility of having carbon capture sequestration is fully exploited. The second one is concentrated solar power and solar thermal energy. Here we are looking at projects that develop even the components, so line focused solar power plants, technology, central receiver, but also systems like cost-effective heat transfer media, digitalization of CSP plant, innovative coating, integration of meteorological forecast, so looking at the overall efficiency and LCOE of the concentrated solar power and solar thermal. Also in this case, it's possible to take into consideration different production of energy vectors with significant contribution to power production targets. Ocean energy mainly take into account direct generation technologies, dry testing of power takeoff for wave energy, tidal stream power takeoff, but also other components. And these are only the priority that have been taken from the set plan, and also considering usually the dimension of the project that are between 1 to a maximum 3 million euro. Sometimes there is not possible to develop real testing in wet condition and in demonstration condition. Therefore, also dry testing are in this perspective taken into consideration. Very important point are the cross-cutting offshore renewable technologies like the mooring and foundations for floating and bottom fixed devices, integrating biodiversity and sustainability. We know that there is a lot of technologies going on and also approach going on in this perspective, and social acceptance of this technology is very important with if we look to mass deployment. So looking at the possibility of integrating offshore technology with sustainable solution here, it's very important, as of course also the possibility of having operation and maintenance and integrated in the technology, facilitating the cost effectiveness of the technology. Marine observation and modeling and forecasting is also a very crucial point for this approach and these sectors. Next slide. Briefly on solar photovoltaics, all kind of advanced PV technologies, digitalization for operation and maintenance, new application through integration of PV, also with other technologies like PV thermal or PV hydrogen could be taken into consideration, always considering power production as a significant part of the energy production output. Wind energy offshore and offshore is also in line with the TRI and with the call module 03 objective, and we look for next generation of wind energy system, digital solution, and digital twins for turbine and optimized wind energy application. We need to also develop energy operation and maintenance and digital tools for improving the maintenance and operation. Lifetime extension, sustainability wind farms, and also site allocation and public acceptance. It's a very cross-cutting important issue for this technology. Finally, hybridization integration. Really, it's important to maximize the site and system integration by co-locating renewable energy source onshore and offshore, like agrovoltaics, but also like take into account in the same site wind and photovoltaics, ocean and wind, CSP and photovoltaics, or whatever you have in mind. But as I said, it's also very important to hybridize the system by combining electricity generation with heat or other energy carriers in an hybrid system, taking also into consideration possibility of improving the overall system by storage of power in different forms. Next and last slide for my I think last slide for my perspective. We of course have some goals and expected impacts. We need to see in the project increasing energy conversion efficiency, so contributed to the zero emission power production development and deployment. Increased technology performance, like being lifetime or even as have been has been mentioned and reported in the set plan. Increase in system efficiency by new modeling approach, tools and methodologies, decreasing investment costs and COE, and improve the overall economic of the energy technologies, but also optimize and decrease the cost by coupling different power production and hybridize them, and of course also contribute to the security of supply, combining different renewable energy. We need also to increase the sustainability by reducing the environmental impact, land use, effect on landscape, biodiversity, and animal life, or significantly improve multiple use of occupied land, surface, or maritime space. We also need to take into account minimize the use of critical raw materials and the extension of the end of life, and apply circularity by design to avoid overconsumption of resources and materials, and to be more, I would say, increased sovereignty in the production of the technology for the renewable power production generation.